So thanks everyone for joining the Glaze webinar series. Today, the title of the presentation is The Influence of Temperature and Daily Light Integral on Culinary Herb Production. My name is Erico Matos, and I'm the Executive Director of the Greenhouse Lighting and Systems Engineering Consortium, and I'll be the host of the webinar today. So like always, the Glaze Consortium webinar series is a selection of live recorded online presentations that cover a broad range of topics at varying technical levels and scale. These webinars feature the latest technological innovations and best practices in the CEA field, providing the audience the opportunity to discover new solutions to connect with experts. Today, we'll hear from the presenters Dr. Roberto Lopez and Kellie Walters, both from Michigan State University, about the influence of temperature and daily light integral on culinary herb production. Roberto Lopez is an assistant professor and controlled environmental extension specialist, and Kellie Walters is a PhD candidate in the Department of Horticulture at Michigan State University. The researcher focuses on quantifying the physiological responses of hydroponically produced culinary herbs and leafy greens to light intensity, temperature, and carbon dioxide with the goal of improved crop quality and yield. A recorded version of this webinar will be available at our website, glaze.org, where you can find all the previous webinars and also register for the upcoming ones. If you have any questions during this presentation, or if you'd like to get in contact with the speakers, please submit your inquiries using the Q&A box at the bottom of your screen. We'll do our best to answer all of your questions by the end of the presentation. So I guess with that said, I would like to give the word to Kellie and Roberto. Thank you so much for being the presenter today, and I look forward for a great presentation.
All right. Well, thank you very much, Erico, and thanks you for having us on today's Glaze webinar. So basically, what we are going to present today is part of Kellie's dissertation. Kellie will be graduating from Michigan State in August and taking on a faculty position at the University of Tennessee. So I'm going to start off by doing the introduction. So why are we interested in culinary herbs? Well, whether it's for basically for food or for drinks, herbs are definitely becoming quite popular. When it comes to production, there's often not a lot of information out there in terms of environmental parameters and how they affect the quality, post-harvest life, flavor, etc. And then, of course, with culinary herbs, especially, let's say, basil, there can be post-harvest issues. Oftentimes, depending on the temperature, storage length, that can affect the visual quality as well as the flavor of these culinary herbs. Next slide, please. Okay. So basically, the goal of our research is really to help growers improve their crop quality while maintaining yield. Obviously, those two things can be challenging. Here's an example of basil. As most of you know, culinary herbs can yield pretty good prices in terms of the amount that's actually sold to consumers, as we can see here, where you have under 2 ounces and you're getting about nearly $3. So in terms of the environmental parameters that we are going to cover in this presentation are the daily light integral as well as the average daily temperature. So we're going to briefly go into some detail in both of those topics. So with the daily light integral, think of it as similar to a rain gauge. So with a rain gauge, what is it that we basically collect? We determine how much rain has fallen within a particular area over the course of a day. Well, with daily light integral, it's basically the cumulative amount of photons of light within the photosynthetically active radiation range of 400 to 700 nanometers that falls within a square meter. Now, when it comes to temperature, we can have, for example, here, we have a very general figure where we have both low and high temperatures. So we can see that the growth rate increases linearly from the base temperature, which is basically the temperature at which development stops, and increases all the way up to the optimum temperature. Beyond the optimum temperature, we start to see a decrease in the growth rate until we reach the maximum temperature. But what happens, let's say, when we have a high daily light integral opposed to a low daily light integral. So that's really where this research is going, and we're going to share some of that information with you today. So the objectives of this study were basically to determine how daily light integral and the average daily temperature within a greenhouse influence growth, development, color, and flavor of culinary herbs, because obviously our main goal is for our consumers to be satisfied with the product that they are purchasing. So in terms of the materials and methods, again, everything for this study was done in the greenhouse. So in terms of the propagation, it was either 2, 3, or 4 weeks, depending on the species. So we had green leaf basil, which was Nufar. We had purple leaf basil, which was dark opal, sage, Extrakta, and spearmint Spanish. Obviously, the Spanish being the fast grower, so within 2 weeks, they were ready to be transplanted. We grew them in rock wool cubes, 200 cell count, and we maintained an EC of 0.78 and a pH of 6. And the average daily temperature, so this is both the day and night temperature, was 73 degrees Fahrenheit. Then the plants were moved to a separate greenhouse to basically finish the crop, where again, they were grown for either 3, 4, or 5 weeks. In this system, we basically had a hydroponic wrap system or deep flood tanks. Again, our EC was 1.56, and again, we maintained a pH of 6. In order to provide our supplemental lighting, we used high pressure sodium lamps. So in terms of our treatments, we used woven shade cloth in combination with high pressure sodium lamps to create daily light integrals from 7 to 14 moles. 7 moles basically to represent the daily light integral that we would naturally have in northern latitudes, and obviously trying to double that with supplemental light. We then had separate greenhouse sections where we were able to maintain average daily temperatures anywhere from 73 all the way up to 95 degrees Fahrenheit.
So in starting with the results, so we have 15 different basil here, and you can see that visually they look different. But I want to preface this with, we repeated all of these experiments multiple times over time, so we'd have a larger range in daily light integrals and a little bit larger range in temperatures than what you see here. But let's delve into the yield results, the fresh mass results. So here we have sweet basil Nufar fresh mass. Let's talk about first this plant right here. So this basil was grown with a daily light integral of about 6 and an average daily temperature of about 75 degrees. It weighs about 20 grams. If we increase the average daily temperature while we still have that low daily light integral, so say we're growing in a northern climate without supplemental lighting, and you want to increase yields, the fresh mass will increase by about 5 grams, so a little bit. If you have the lower temperature and you don't want to spend money on heating, but say you add supplemental lighting, or it's later in the spring when the daily light integral is 12 to 14, the fresh mass will increase by about 9 grams, so by about 50%. However, if you have a higher daily light integral, so 12 to 14, and increase the temperature to about 95, you'll have an over doubling or a 200% increase in fresh mass compared to the temperature of about 75. Similarly, if you have a higher temperature and you add supplemental lighting, you'll have, again, an over doubling in fresh mass. So this plant that's grown with a higher daily light integral and a higher average daily temperature is about 60 grams compared to this 20-gram plant. So if you have a higher daily light integral of, say, 12 to 14, you can increase the temperature to 35 to get the highest fresh mass. But if you have a lower daily light integral and cannot increase that integral, it's more effective to only increase the temperature up to around 85. If you increase it above 85, you'll have a slight reduction in fresh mass. So if you have that lower light intensity, and it's really hot, either cooling to 85, or if you want to increase fresh mass and you don't have supplemental lighting and you're using heat as your strategy, don't heat beyond 85 degrees. So moving on to sage. So sage, the axes are a little bit different here, so you can see the graph. But again, we'll start with this plant that is grown at a low average daily temperature, well, low for this study, about 75, and a daily light integral of about 6. So it is 35 grams. If you say, okay, I want to increase my sage yield, I am going to increase the temperature. But with this low daily light integral, if you increase the temperature to 85, you'll still have a pretty similar fresh mass. And then if you increase it above 85 degrees, you'll actually have a decrease in fresh mass. So say you're growing in a really hot area and you cannot cool, maybe a strategy would be to increase the daily light integral. So if you increase the daily light integral when the temperature is hot, from about 6 to about 18, you'll have a pretty similar fresh mass. A slight increase, but it's pretty similar. So if it's hot, the best DLI for the maximum fresh mass is about 11 to 12. If you can cool to maintain temperatures between 75 and 85, you'll have pretty similar fresh mass when the daily light integral is higher. So the overall recommendation for sage was it would be to maintain a temperature of 75 to 85 and a daily light integral of 12 to 18, 19 for the maximum fresh mass, because when you get hotter, the plants don't do as well. Similarly, you know, if you have a higher temperature, if you can cool, you can really increase your fresh mass, or a higher daily light integral if you can reduce that temperature. Moving on to mint. Again, we see a pretty big difference in the size of the plants based on the light and the temperature. Again, we'll start with this plant here was grown with a lower daily light integral of about 6 and an average daily temperature of about 75. If we increase the temperature to about 85, we see about a 9-gram increase in fresh mass. So this small plant weighs about 13 grams, then just over 20 grams for the plant grown with a low daily light integral and again, an average daily temperature of about 85. If you increase the temperature above 85, while maintaining that low daily light integral, you'll see a reduction in the fresh mass. So again, don't heat too much for mint, especially when the daily light integral is low. If you have high temperatures and you increase that daily light integral to about 18, you'll see an increase in fresh mass of about 8 grams. But if the temperature is lower, so about 75, and you increase the daily light integral, you'll have about a 4-fold increase in fresh mass. And an even greater increase if you increase the temperature to about 85. So for mint overall, if you maintain the temperature around 85 degrees, that's optimum regardless of the daily light integral. But whatever temperature you are at, if you increase the amount of light the plants are getting up to, we only have data for up to 18, 19 moles of light, you will have an increase in fresh mass for mint. So moving on to purple basil. I like this picture just because it's so stark. The plants look so different, especially compared to some of the other crops we were talking about. But you can see not only size differences, but color differences. So what does this look like when we plot it? So again, we'll start off with this plant that was grown with a lower daily light integral and of about 6 and an average daily temperature of 75. So this plant weighs about 9 grams. If we increase the daily light integral to about 18 grams, we'll see a 4-fold increase in fresh mass. So this purple basil on the left, it weighs about 40 grams. So maybe you don't have supplemental lighting, you live in a northern climate and you want to increase the mass of your purple basil. So you say, okay, I'm going to increase the temperature. But if you increase the temperature to about 95 degrees, you'll have a similar increase in fresh mass, but your plant will look vastly different than if you increase the daily light integral. So you can see here that, you know, the plant grown at the higher temperature is very green. And that is because some of you might know, but the anthocyanins are not synthesized as well when the temperature is high. So you need lower temperatures to have the greater anthocyanin production. So when you're growing purple basil, you're really growing that purple basil for that deep purple color. So if your strategy is to only increase mass and you don't care about the color, I would recommend choosing a different cultivar besides purple basil, because a lot of the green basil cultivars do yield more, they grow more quickly than the purple basil cultivars. So say you have a high daily light integral and say, okay, I'm going to see if I can increase the temperature now to increase fresh mass even more. You can increase fresh mass more, but again, your plant will be more green. So there's a little bit of purple in there, but it's still a pretty green plant. So whether you increase the temperature to 90 to 95, yeah, the plants are pretty green. So a better strategy the best strategy to increase biomass while maintaining quality for purple basil would be to increase the daily light integral. And don't increase the average daily temperature much above 80, or you'll start getting very green plants. And again, this is cultivar dependent, but in general, as you increase the temperature, you'll get less anthocyanin production and less purple, more green plants. Another thing you probably also noticed in the pictures was that the size of the leaves were vastly different. So this plant here, this sweet basil Nufar, was grown at 73 degrees. And the size of that leaf is about the size of my hand. So it's pretty large. As we increase the temperature from 73 to 95 degrees, the size of the leaves are about half of what they were at the lower temperatures. So this is something to consider as well when you're trying to produce a consistent crop, say for a market, you know, over and over again. That if someone gets used to getting basil leaves the size of my hand and then it's, you know, half the size, it's quite a big difference. But we not only see this, this Nufar cultivar is probably an extreme example of the leaf size change, but we also see the size of the leaves decreasing as temperature increases with mint, sage, and purple basil. So this is across all of the crops that we have been working with.
Okay, so basically what I'm going to do is now give you just a brief outline of the results. So basically what we found with pretty much all of the species that we worked with is that when you increase, or in order to increase the fresh mass, at least for sweet basil, either increase the average daily temperature or the daily light integral when the other is high, meaning that if, let's say you increase the average daily temperature and the DLI is low, you're really not going to see much of an increase in that fresh mass. What else? The quote-unquote optimum temperature is typically higher when the daily light integral is higher. So that's just another way to look at it. So with some of the other crops, let's say in terms of fresh mass, increasing that daily light integral is obviously going to increase the fresh mass. With the exception of sage. So we found that sage was basically one of those species where you should grow them at slightly cooler temperatures in order to really increase the yield. So let's say for sage, increase your temperatures between 75 to 84, with mint up to around 84, and with purple leaf basil, 95 when the DLI is low, and 90 when the DLI is high. So something that we have not tried out, which I think would be interesting with purple basil, is to see if we can increase anthocyanins with light quality, so with the LEDs. because we have found, let's say with lettuce and as well as even purple fountain grass, that you can definitely increase anthocyanins that way. So that's something I think we might try out in the future. So in terms of visual characteristics, obviously there is that balance between the biomass and the color, as Kelly went into. When you increase the temperature, obviously with the purple leaf basil, you're going to have less purple color and more green. So increasing that daily light integral is obviously going to help in that situation, dependent on your location. And lastly, increasing temperatures are going to result in smaller leaves. So that can obviously have a big impact dependent on the end use of the product.
Okay, so what about flavor? This is something that we've been interested in, as Roberto talked about a little bit in the introduction. So we're growing culinary herbs, and of course we want good yields, but we also want the consumers to keep buying our produce. So we want to have good quality crops. And part of that is the visual characteristics that we spoke about earlier, like the color, but also the taste. So we delved a little bit into investigating the taste of basil and how it is influenced by these different environmental parameters. So just because it's something that, you know, we don't normally, you know, a grower doesn't usually measure the taste of a crop, but it's much easier to measure that fresh mass because that's what you're selling anyway. So if you're manipulating, say, the light and you're manipulating the temperature to increase that fresh mass, you may be changing the flavor of your product without knowing it. So today we'll talk about some of the compounds that, we're just going to talk about sweet basil. So some of the compounds that make up that characteristic flavor of sweet basil and how they change in response to temperature. And then we'll talk about a little bit about what consumers prefer. So first, we have, again, on the bottom, our different temperatures of our experiment. And then this is a plot of the compound 1,8-cineol, or eucalyptol. And so this compound basically smells and tastes like eucalyptus. So as you can see with this line here, as the temperature increases, the concentrations of this eucalyptus-y compound, or the concentration that gives the eucalyptus-y flavor, increases. We also see that the eugenol, or the clovey flavor and aroma, increase as well. And so does the anisey flavor in basil. And it was interesting because some of the consumer panelists said, this is licorice, tastes like licorice. So you can identify some of these compounds. Think about it next time you eat basil and try to think about the different flavors that you're tasting. So again, this increases with temperature. And then another major compound, linalool, I think it smells like Fruit Loops. It's also described as slightly florally, but it's in a lot of different plants. But there was no significant change. So there was no change in response to temperature. So some compounds increase as temperature increases. Other compounds don't change at all. And other compounds decrease. So like those anthocyanins, they decrease as temperature increase. But again, the flavor compounds in general, a lot of them increase as you increase the temperature. So this is what we measure in the lab, but what we really care about is what consumers want. So can they tell the difference between the flavors? Do they even care about the difference? And if they do care about the difference, what flavors do they prefer? So what we found was that overall, there was no difference in preference between the plants grown at 73 and 95 degrees. So they were all the same preference-wise. We asked them to rate a bunch of different characteristics on a Likert scale ranging from, so it's a scale that ranges from dislike extremely to like extremely. And there were different characteristics like aroma, aftertaste, flavor, bitterness, sweetness, along with some visual characteristics as well. And what we found was that there was no difference in any of the taste or aroma preferences. So there was no difference in that. Even though we could measure differences in the compounds, there was no differences in preference. But there were differences in some of the visual characteristics, like appearance, texture, and color. So overall, the consumers preferred the plants grown visually at higher temperatures. But overall, there was no difference. So that's one thing that you don't have to take into consideration as much when manipulating the temperature. So while it changes some of the concentrations, it's not enough to significantly change the flavor where consumers actually care. So we also did, we did a series of different studies, and a couple weeks ago we presented on how light influences flavor and consumer preference. And just because temperature doesn't influence it much, light actually does quite a bit. So we had daily light integrals ranging from 6 to 35. And as you increase the daily light integral, the concentrations of these different compounds increased, but the consumer preferences for those changed as well. But you don't have to worry about that for temperature. So overall, for the sensory characteristics, the compound concentrations change. So we can see that in the lab. But when we ask consumers what they prefer, there was no effect on their flavor preference or their overall liking. But consumers preferred those grown from 84 to 95 degrees visually the most. So with that, we'd like to thank everyone who has helped us. There was a lot of people that were involved in all of this analysis and work in measuring all the plants, and a lot of support and funding as well. So sorry if I talked a little fast on that. I'm glad there's a recording. I just get a little excited and I just talk. But if there are any questions.
Thanks, Kellie. Thanks, Roberto. No, it blows my mind what you guys are doing. So many options, so many possibilities, so many controls. You're pretty much laying out all the options, right, for the growers. And I think, in a sense, you're giving growers more trouble now. There's so much things now to choose from. I don't know. It's great that we have the questions here. We have I saw some questions from growers. But even for them to define biomass versus color versus taste versus growers' options, and plus the economic aspects, right? We haven't even talked about the pricing and all of that, but it's so interesting. Thanks so much for the presentation. I have a few questions, but I want to start with the questions from the audience, and then we can go back to some points, if we have time, some points that I have in my mind. So the first question is, how does CO2 enrichment play a role in temperature manipulation? Can CO2 be used to increase mass when DLI cannot be increased? Or similarly, can you increase CO2 when temperature cannot be increased?
So, do you want me to take that one, Kellie?
Yeah, sure.
Okay. So, unfortunately, let's say that you are providing optimal light. So you're using supplemental lighting, and let's say you have a daily light integral of 20 moles of light, but there's a CO2 limitation, so your greenhouse is very tight, and basically, those plants are utilizing CO2, and there's not very much air exchange. You're basically wasting money, because what do the plants need in terms of photosynthesis? They need light, they need carbon dioxide, and so when you're limited in, even temperature can have an impact on photosynthesis. So being limited in one of those three categories is not going to allow you to have the optimal yield. So,
and elaborating on that, we did some experiments with carbon dioxide, but not, but it had a constant temperature. So it was just the interaction of carbon dioxide concentration and light intensity at the seedling stage. So nothing to do with temperature, but at that seedling stage, there was no difference in elevating carbon dioxide concentrations. So that's something that, temperature could, the interaction of temperature and carbon dioxide could be an interesting avenue to investigate.
I have a follow-up comment here because Roberto now and Kellie, you mentioned about these three. You mentioned three of the inputs, right? Temperature, CO2, and lighting. When you do those studies looking for the interaction of all those factors, how are you doing as far as climate control? Are you programming individually each one of those? Do you have an integrated control system that can make decisions if one change, what happens to another? Is that something that you already have a commercially platform to play with that, or that's something that is another potential area for development, something that can integrate all these calculations in one brain or one climate control system?
So we don't have anything very high tech in the greenhouse. We just have a Priva system that we manipulate and look at the temperatures every day to make adjustments so we can maintain our target temperatures. The growth chambers, of course, are a little bit more tight, but for all of this work here, it was all in separate. So we had 5 separate greenhouse compartments that we maintain temperatures. So nothing crazy that's beyond, you know, what normal controls are commercially available now. But I mean, we're, you know, creating these equations and these models to predict, you know, what the optimal DLI is based on the temperature. And you can, if there's some, you know, sort of way that we haven't developed, well, we haven't developed them. We're just developing these equations, but to integrate them into some system, I think that could be beneficial.
Right, yeah, absolutely. That's another opportunity. So going to the second question, we have a grower from Georgia asking that, so in Georgia, temperatures can run over, oh, sorry, it's not saying Basil, it's just saying a grower from Georgia where temperatures can run over 100 Fahrenheit heat throughout the day and then goes down to 60 during the night for the summer. How does the extreme midday temperatures impact all these equations and these protocols? So I think the question is the true average that we are after? Or yeah, I guess it's really a steady average throughout the day, or do you take in consideration these highs and lows throughout the day?
So it's really the average daily temperature that the plant integrates in terms of how it affects development. Obviously, when you have let's say a large difference between the day and night temperature, that can have morphological effects on the plant. So let's say that your day temperature is warmer than your night temperature, you'll see elongation in the plant. You may see some differences in the size of the leaves, but or likewise, when you have a cool day and a warm night, you'll tend to have more compact plants. But again, especially with a hydroponic system, you're not going to see as much stress on the plants. Let's say that when you go over 100 degrees Fahrenheit, as you would in a potted system, because obviously the plants are consistently in moisture, but there is a point where you start to see heat stress, and that could have an impact on yield.
So you do have a maximum threshold and a minimum threshold for temperature throughout the study, or do you go with the environment?
So with this study, we maintained a constant temperature day and night.
Right.
Yeah. And if it was going to be a hot day, we knew to adjust the environmental controls to make sure we maintain that temperature. But yeah, I think, you know, in regards to flavor, it could be, you know, the stresses can impact the production of different secondary metabolites. And I don't know of a lot of research. We wanted to have this foundational research first, just trying to maintain everything as precisely as possible. But that's another question. What happens if you have big temperature spikes, and how does that affect the quality of the crop?
Sure.
I'll just add that we are going to be conducting a study this summer where we're going to look at kind of extreme day and night temperatures with and daily light integral and its effect on potted culinary herbs.
We're going to look forward. I think I'm going to have to schedule another webinar after the summer. Okay, so the next one. Does water temperature make a difference?
So we did not change water temperature. We measured it though in every treatment, and you know, even though the air temperature was 95, when we had more shading, so we had the lower daily light integrals, the water temperature was a little bit cooler, but that wasn't one of the parameters that we manipulated in this study. But I think it could be, and I don't know of a lot of research that has investigated this. I'm sure someone might have dabbled in it, but it could be interesting. Maybe you could chill the water when the temperature is too high. That could be a more effective strategy, but I don't know. Roberto has done a lot of work with root zone heating and ornamental crops, if he wants to elaborate.
And there it's really genera specific in terms of how the root zone temperature affects the crop. So if it's what you could consider a cool season plant, warm root zones can actually negatively impact the crop. And when you have a warm season crop, as you increase that root zone temperature, you typically tend to see an increase in development, obviously up to a certain point. So anything beyond, let's say, 85 degrees Fahrenheit for most herbaceous annuals starts to have a negative impact.
Right. Another question related to the methodology. How was leaf color measured?
So we measured leaf color with a colorimeter. So it's this, they actually use it a lot in like different plastics, and we borrowed it from the post-harvest lab. They use it to quantify blueberry color and apple color. So we use the colorimeter to measure the color of the leaves.
It's a non-destructive method of measuring color. So it's not necessarily measuring anthocyanins, but it's measuring can't think of the name right now, but basically gives you a scale, so then you can determine how, let's say, green or red or yellow or blue a particular item is.
Okay.
Yeah, the LAB values.
Yes.
We have a question which I think Roberto talked a little bit during the presentation. It's in regards to purple basil color. Wouldn't UV or any lighting effects, I guess, provide a higher influence on leaf color than the DLI and temperature? So the lighting effects on color would be more pronounced than the other two factors?
So yes, light quality will definitely impact, or I should say radiation quality will impact leaf color. However, when you're at very warm temperatures, you kind of have that negative effects. So again, we haven't looked at that, but I think that would really be interesting to see how radiation quality could impact even with UV light. Obviously with UV, you got to be careful of not providing too much, or you could easily damage your crop.
But yeah, daily light integral is still important for increasing biomass.
So you have this relation, right? Yeah.
Yeah.
Okay, so another question. Did you monitor vapor pressure deficit or humidity among the different test groups? If the VPD was not consistent between the different groups, could this be an additional variable impacting the growth outcomes?
So we have that data, but I haven't looked at it yet. We grew all of these hydroponically, so at least there was not differences in water uptake from the root zone perspective. But I haven't looked into the data on the VPD.
In most of our studies, we try to keep it around 0.7 kilopascals.
Great. The next one, did you see any physiological disorders related to the environment throughout the experiment?
For these crops, no. We didn't see any disorders for these crops that we grew.
Cilantro tends to be one where you see some disorders, but yeah, we didn't, at least not with these four.
Okay. Yeah, we have a few questions that go around, so different questions, but they're all around asking if you've done any experiments in vertical farms using sole source lighting. So they're all in greenhouses, or do you have anything with exclusively electric lighting as a source of light?
So, Kelly, do you want to talk about it? And we can refer you to the Indoor Ag Cafe webinar series, because we have a recording that we did in April, so you can learn more about what we've done indoors, but Kelly can kind of give you a little brief synopsis of that.
Yeah, so really indoors, we've been investigating the interaction of light intensity and carbon dioxide concentration. So we had a bunch of different culinary herbs, basil, and in the Indoor Ag Science Cafe, we talked about basil, but cilantro, well, not cilantro, parsley, dill, watercress, sage. But yeah, what we found was that in the indoor setting, I'll just talk about basil for a bit. Increasing the light intensity from 100 to 600 micromoles for a 16-hour photo period. So increasing the daily light integral from about 6 to about 35 resulted in, I think it was around so we were working with basil seedlings, and you may think a DLI of 35 is too high, but basil actually did well. So increasing the light intensity that much, we had an over 270% increase in fresh mass. And then after that 2-week propagation time, we transplanted those basil seedlings into the greenhouse and grew them out for 3 weeks, which is what we did in this temperature study as well. And we still saw an 80% difference in fresh mass between the seedlings grown under 100 micromoles, or DLI of 5 to 6, compared to that high DLI of 35. In regards to flavor, there's a huge difference in flavor. And the consumers actually thought that the basil grown under daily light integrals of 28 to 35, they were much too flavorful because they're just tasting the leaf, and they're like, this tastes like black licorice. They really picked out that methylchavicol. So they preferred the basil grown under around 200 micromoles, so a DLI of about 12. So that was all sole source work that we did.
Great. Yeah, and I saw Roberto share the link here it's on the Q&A or the message, let me see, the message box. So there is a link for that Indoor Ag Science Cafe where you can see the entire talk about that. There is another question here which relates to that, but I think it's hard to give a right answer here, which is how to choose the perfect composition on what you want to grow. And that ties together to another question, which is asking about growers consumer, how this growers consumer affects those decisions that growers, the final client consumer, affects the decisions that the growers needs to make with the production systems settings and everything that we did with temperature and dial for one of these outcomes. So what is your comments there? And I would even add to that, to make a little bit more complicated, what would be the best option, going indoors or greenhouses where you have those culinary herbs that you can get a lot of value aggregated to that? Is there a right answer to that? Is there a one answer to that?
So, sorry, I started reading, I opened the chat box after you mentioned Roberto's thing, so I missed the beginning of the question. But was it regarding like what's optimal and should you grow indoors or in the greenhouse? Is that the
Yes. The question, it was a mix of 3 questions. So it was, what is the optimum selection? So what is the optimum parameters to grow your herbs? But then there is another question asking, what is optimum for consumers? So I think it starts to mix there. And then I add a third point from my mind, which is, then you go for indoors or you go for greenhouses if you want to control all that. So it's a more strategic question, I guess. So any thoughts about that?
It depends. No, I mean, it does. So some of the work that I hope to get done sometime soon, stats are crazy, but we have a lot of consumer preference data. So we have almost 300 people that have tasted our basil. And with this, we have a bunch of demographic information. So say, you have this really high flavor. Some people really hate it, but some people really love it. Maybe Roberto loves black licorice. Well, I think it's terrible. So based on that, and some of this analysis has been done with there was just a paper that came out, I think in Hort Science or Hort Tech, about melon preferences. But we have all this data, and we can, based on, people like Roberto, like the, more flavorful basil, and I like the less flavorful basil, we can start to segment the market and really provide the information to growers on who they can target and to provide this higher value crop. Because, I mean, greenhouse indoor production, it's more capital intensive than outdoor production. So what we can really leverage is the quality of our crop. And part of that is, again, flavor. So maybe if you're growing under a different light intensity or a different temperature, you can market a more flavorful crop or a ready for salad crop. So I think, yeah, that part depends. And with temperature, like with purple basil, again, you want to make sure you have that balance between biomass and color. And yeah, that will depend on cultivar too, and yeah, how you produce the crop. And then your energy costs as well. So I think it's a balance between everything, and there's not one silver bullet. Do you want to add anything, Roberto?
Sure. One thing is if you're trying to provide a consistent product year round, indoors would obviously, you'd be able to do that because as Kellie showed, plant architecture, leaf size is going to be ultimately influenced by that temperature. So, if during the winter your leaf size is going to be large, during the summer you're going to have smaller leaves. Also dependent on maybe if that's not necessarily the case and you're selling your product not for the fresh market but more for processing, let's say to make pesto, then that might not necessarily be as important, and greenhouse grown or even field production might be more cost effective.
Sure, and there is one question I think related to that. We can tap into this one topic here, which is regarding the flavor. Why do you think people prefer the basil exposed to higher temperatures? Were the leaves greener, smell better, or do you think there is any other reason?
Yeah, so there was no difference in preference for aroma, taste, aftertaste, bitterness, sweetness. So all of those like taste characteristics, the increase in temperature didn't change what consumers preferred for temperature. But some of the visual characteristics, so color, and in that picture we didn't really see a big difference in color, but maybe there was some, basil gets interveinal chlorosis pretty easily. There might have been a little bit of discoloration, or with that larger leaf size, and the texture could have been different. So the leaves tend to be a little bit more wavy, whereas at higher temperatures, they tend to be much more smooth. So we don't know exactly why. What about the texture that they liked more? We can delve into some of their comments, but overall, they just preferred that texture and color. And I can't remember what the other one was. Yeah, the overall appearance. So some of it might have been the leaf size. Maybe they liked the little bit smaller, more normal size leaf than that gigantic leaf of the plants grown at the lower temperatures.
Yeah, that's a tough one, right? So personal. Some people will like something, some other people like something else. It's a hard question, this one. So there is one about the time for the trials. There are two questions around that, so I'll combine both of them. One question is asking, how long was the growth cycle for the herbs that you tested in the greenhouse trials? And then someone else comments saying that the findings are 3 to 5 weeks after transplanting, whether these finds remain the same if you go to the commercial harvest. So there's these two questions about the timing of the crop.
So each crop was a little bit different just based on how fast they grow. So basil and mint were 2 weeks. So mint was vegetatively propagated. So it was about 2 weeks, just under 2 weeks under mist, and then we had to take it off mist and then transplant. Basil, the seedlings were grown for 2 weeks. Purple basil was 3 weeks, and sage was 4 weeks. And then in the greenhouse, so the seedling stage was all a common environment. In the greenhouse, basil and the mint was 3 weeks, purple basil was 4 weeks, and sage was 5 weeks. So we determined that those production times were, at the higher temperatures, we had a pretty large crop. So we thought that those production times were appropriate. It's like some of the purple basil, if you're growing under a low DLI of like 6 and a lower temperature, you're going to have to probably have a longer production time in order to get, you know, the biomass per plant. But another thing that's different is that we had 1 seed per cell. So these are just individual plants, and maybe you're growing with, you know, a bunch of plants per cell, and that would be a little bit different. And I know Roberto, this summer, the studies that he's going to do, he's going to have multiple seeds per pot to be more similar to commercial conditions. But what we really wanted to do was create these baseline models to show the trends.
Sure. Yeah, that makes a lot of sense. You lay out all the capabilities, and then each one can apply according to their needs and requirements. I think that, yeah, that makes perfect sense. So there's 2 questions now that will combine again. And the questions keep coming, so I'm glad you gave a lot of time for that. So the questions about the cultivars that you use and whether they would grow under different conditions. So one question is saying here, if the basil could be grown around 30 degrees C, and if there are species that could be grown in temperate regions. And the other question is, how were these crop varieties selected for the testing? So one, if they could grow under 30 C and they could grow in temperate regions, and how did you choose the varieties that you used for this experiment?
Yeah, so basil can definitely grow at 30 C. So that's around, you know, a little over around 90 degrees Fahrenheit. So yeah, it grows pretty well. Whether it's green basil, but purple basil, you'd have to investigate different cultivars, because the cultivar that we use, dark opal, it definitely turns much more green when you get to temperatures around 30 Celsius. Other crops like sage, it can grow, but if you can have a little bit cooler temperatures, that would be better. Mint grows well at that temperature as well. So as for cultivars, so we chose Nufar based on a study that we conducted at Iowa State a few years ago. And we grew 35 different cultivars of basil. And this was the second highest yielding cultivar. Italian large-leaf was the highest yielding cultivar that we grew, but Nufar is fusarium resistant, so that's why we decided to go with Nufar. And dark opal, again, you know, we grew all these different types of basil, and dark opal was one of the highest yielding purple basil cultivars. And again, maybe there are other purple basil cultivars that respond differently to high temperatures, like maybe some of them retain their purple color a little better. So that would be interesting to look into if you're doing variety testing for yourself.
Great, thanks, Kelly. There is one question here about the economic impacts of all these decisions. I don't think you talk about the costs, and you didn't take in consideration, at least on this presentation. I don't know if you have this information or not, but that's a great question, which is, what is the relation between light and temperature in a more advisable and more economic way for a grower? So if they have to balance the costs of provide supplemental lighting, controlling temperature. So the question is, did you evaluate it? And have you measured the chlorophyll values? I think, well, the chlorophyll value is a separate question. Let's go for the economic impacts. So did you guys look into that, into the costs of controlling all of that? And I will expand the question into an installation cost. So having the equipment capable to do that, and also the operational costs on how much you're paying for lighting, electricity, and for CO2, and to control temperature and so on.
So we have not done that yet, but actually when we did the Ag Science Cafe, Cherry Kubota gave us some ideas on how to calculate it for indoor production, and we'll probably try to look at it as well for the greenhouse production side.
Yeah, I think that's a very applied question, right? I think every grower would be interested in that. The second question for every grower, I guess. Okay, I can do all of that, but how much is it going to cost me to do all of that? But it's nice. So, Kelly, you mentioned at the beginning that you're doing all of that using a previous system. So I think, right, climate control companies would be capable to do all of those one way or another. You might take more work or less, but then these economic questions or evaluations would be the second question for most of them, I believe. All right, so let me see here. We're getting close to the questions. We have another one talking about humidity. I guess you already answered that, and would be true for this question as well. Was the humidity the same across all of the temperature treatments, or was it varied to maintain a specific VPD?
Roberto, do you know more about it?
So, like I said before, our goal is to maintain a 0.7 VPD. So as Kelly said, that's one component that she has not incorporated into her models yet.
Right. Another one about the quality of the produced crop. Does the high temperature affect thickness or crispiness of the leaves?
Again.
Yeah,
Oh,
so we didn't measure that, and that's one thing that I wish we would have measured, especially with higher light intensity. So we know, if you have a higher light intensity, you tend to have thicker leaves that can be more crisp. But unfortunately, we didn't do that. It was too late before I realized I should have measured that. But I don't know for sure. One thing that I do think could be a factor is post-harvest life. So how long does it take until these start to wilt? And how does the pre-harvest environment, what we're studying now, influence that? And we haven't looked into that, but I think it could be an interesting avenue to investigate in the future.
One thing I'll add is with our current Optimia Specialty Crop Research Initiative grant, we're going to be looking at the post-harvest quality of leafy greens as they're affected by light, temperature, and CO2 during production. So yes, but there is that possibility that you can increase yield and such, but that could also have a negative impact on how long the product lasts, right? And so that's one component we're going to investigate.
And I would assume for those crops, right, for culinary herbs, that must be extremely important. So if you don't have this shelf life, that would be a big problem, for the audience or for the final consumers. Sure. We have time for one more question. It's almost 3. Let's go with this, which I guess you briefly talk about this, but just for further clarification, Roberto, you talk about that. Could you share whether the average daily temperature was constant through 24 hours, or was that different between day and night?
So our goal was to maintain a constant average daily temperature day and night. Yep. Right. And there's a question that I could quickly answer. It says, do we have any results for Mizuna? And actually, I did a webinar as well that's also on the Optimia or Egg Science Cafe website on microgreens. So if you want to look at that, it is, give me a second here. I thought these were numbered, but it's towards, it would be number 10 in terms of the webinars if you want to take a look at that. Find out some information on how light, quality, and quantity affect microgreens. Where they can find that, Roberto? In the same link that I shared earlier. All right. Yeah, I don't know if everyone saw that. So it's the www.scri-optimia.org/cafe. Is this one? Correct. All right. So if people go to the SCRI Optimia website, they can find all of those. Great. So I guess a last point here, Roberto mentioned that Kellie just got a position as a faculty in Virginia. Is that right? Virginia, you mentioned? Tennessee. Sorry. Yeah. And then we have a question here. What is the position focus on? So I think that's a great opportunity. If you want to just say what you're going to be doing in the future so people can know how to refer to you and where to find you. If you don't mind giving a 30 seconds information, I think people would find interesting. Yeah, so I'll be in the plant science department at the University of Tennessee in Knoxville. My position is a controlled environment vegetable physiologist. So I can still, work with culinary herbs and leafy greens, but also vegetables in controlled environments like high wire crops. So it's a pretty heavy research appointment, and I am very excited because I'll have the analytical capability in my lab to continue some of the quality work and expand on it from what we've been working on lately. So that's my plan for, starting September 1st, I'll be in Tennessee.
See, there are good news in 2020.
Yeah.
There are good things happening in 2020. Thank you so much, and congratulations, Kelly, one more time. Well, thank you so much for the presentation, Roberto, Kelly. Do you have any other final thoughts, any final comments, any final links you want to leave here, any information?
I think we're good. Thank you,
Thanks
though.
for attending,
Yes.
everyone.
Thank you.
And thanks for
That was the longest Q&A session, right? That was 30 minutes, and we could still keep talking here. So very interesting. Thanks everyone for joining the webinar. And I see you everybody, hopefully on the next webinar. We don't have a date yet, but we're going to be talking about workforce development in the CA industry. So it might be very interesting for everyone as well. I hope to see you again in a month from now. Thanks, Roberto. Thanks, Kelly. Thanks everyone for attending. Have a good day. Bye-bye.
All right. Thank you.